things are getting more and more internationalized. Fusion, the biggest project which is going on in fusion is the International Tokamak Experimental Reactor, which is being built in Cadarache in France, and India is a full member there. And just like we provided for the Large Hadron Collider, we are going to provide a lot of equipment for this, and particular cryogenic equipment. The cryogenics for that is something like 3 floors high, and it's being built by Indian engineering industry. And if Indian engineering industry is to build it, the manpower has to be developed by our top engineering institutions, including the NITs. Of course, we are able to do that. We have our own superconducting steady-state tokamak in Gandhinagar near Ahmedabad. This is what I meant by our national knowledge network, which we are setting up. This is a guaranteed service network. We have got what we call points of presence. I chair this high-level committee for the NKN. We have what we call the 31 POPs, points of presence, which are there in the capitals. You can see by the circles that you see. And we have a consortium of national service providers for this. BSNL, MTNL, RailTel, Power Grid Corporation, which are connecting these. And every point is connected to every other point by at least 2 routes. So it's not a best possible service, but it's a kind of a guaranteed service. And India is able to do this because we don't have legacy networks. You know, countries which started earlier, they have a metropolitan network, they have a state network, then you have a national network. To go to the national network, you have to hop from one point to the other. Fortunately, we can do that. And once you are in these main POPs, then from there you go to the edge institution, which will be one of the universities or one of the national labs and all that. A gigabit per second is provided and to the various knowledge institutions. All NITs are connected, by the way. And the main backbone will rise from, right now it's 10 gigabit, it will raise it depending on the demand to 100 gigabit per second. And already about 1,000 are connected. It's heavily operating used network. It encourages, you see, regional, international research collaboration. And also, as I said in the beginning, NKN is an integral part of the e-science infrastructure of India. And we are connecting it. European Union grid and this are connected. And to the west, we want to connect it to, say, the internet to the US or Canadians, Canary. And similarly to the research and education networks to the east of India. We have already used it for many applications, and for example, when you started the new IITs, there was no faculty. You only said IIT Hyderabad will be mentored by IIT Madras, IIT Chennai. But how many times can a professor go there? So this was in 2009. You know, we talk about bureaucracy in India. But this project, because the Prime Minister had blessed it, we started before the Cabinet gave the approval. We started the project. So things can be done in India if you want. And the way we did it we used the NIC facilities, National Informatics Center facilities. And we didn't spend any money. And all these regional service or the service providers, BSNL or RailTel, they said, we'll give you free for 1 year until your project is sanctioned. And of course, we paid them back. And that is why we started providing this virtual classroom support to the new IITs, lectures being given and in the mentoring IITs. Now, this is not the only way you can use it. Of course, you can do it also for NITs if you like. If NITs want to use it, old NITs or the established NITs, in specific subjects you want to mentor the new NITs, it can easily be used. You need all the standard things are there, virtual classrooms, high resolution, because it's a low latency network. Low latency network. You almost feel like talking to each other. So the students can ask a question and the answer can come immediately. There isn't a pause like you see on the TV when somebody is being interviewed. But then you multiplex and it opens up and then he comes online. And one of the important applications we are looking at in areas where we don't have adequate manpower, like cyber security or some areas of neuroscience. I'm sure there are such areas in engineering. Equal quality faculty may not be available in all the institutions. In some part of that subject, best quality may be in, let us say, NIT Surathkal. I'm just saying. Maybe NIT Trichy or NIT Calicut or NIT Bhopal. This place is full of Bhopalis. What do you say? More Bhopal than. So, what one can do is, the lectures are all given in the various NITs, but if you can work out the logistics, all the students can hear all the lectures, can work out the logistics. Or the alternative is put everything into a cloud and let this NIT decide, each NIT decide what part of the course. Somebody may need 50% of the entire course, somebody may need 10%. You can pick out whatever you want from it. And of course, like IITs have done NPTEL, you know about NPTEL, which is all archival courses. They are all put in an archive. You can do that, NITs can do that. And you draw from it. 3 years back when I was chairman of the Board of Governors of IIT Madras, Professor Anant told me that at that time they had already had 4 million hits. 4 million hits to these and 2 million from outside. 2 million from outside India, outside India. You can, as I said, you can do remote experiments. See, my friend in Bombay uses the synchrotron sources Grenoble sitting in Bombay. He's also a protein crystallographer, Hosur. What he does is he sends a dozen protein crystals to Grenoble. It is loaded on a robotics arm, and one by one the crystal comes to the X-ray beam line. They study the diffraction pattern as observed in Bombay, or it's also being done from Calcutta and Bangalore. You select which is the crystal which is diffracting the best. Having selected the crystal, all the entire diffraction data is then obtained and transmitted live to, it's possible through the National Knowledge Network. We are also trying to robotize our own beam lines in Indore. This will be the trend it will go. You don't have to travel, you just sit in your place. You see the logo of NKN on the left at the top, which was designed after a great deal of interaction with us. On the screen, if you see, where is it? On the top over there, NKN. There is a blue N because it also involves blue sky research. Blue sky research. This kind of optical fiber network is not, doesn't use a static technology, something which is going to continuously evolve. So we encourage basic research in this area by the various organizations. The green N means it's a green technology. If you don't travel and you talk across using the fiber, to that extent you save aviation fuel, so you emit less carbon dioxide and hopefully reduce the threat of global warming. And if you read it carefully, the whole purpose is KI that you see there, knowledge integration. Knowledge integration is the purpose of this. Now, you can create grids for within, you can overlay it or you can connect whichever way you want, various, of course, NKN webcasting is very simple. Have a leading guy giving a lecture, you just webcast it, because everybody is connected. Suppose you have a Nobel laureate visiting one of the NITs. Entirely up to you to say, or some conference is being held, you can transmit it to any other NIT. Or grid for climate change. Ministry of Earth Sciences has connected all the labs, IITM, tropical meteorology in Pune, IMD, maybe some of the IITs which are working in this climate change area, they are all connected. They can share. You can have a brain grid. So when I was in McGill, Montreal, 2 years back, they told me about a project they have, they call Canada Brain, Sea Brain. What they said was they have connected all their brain research related institutions through their network, which is called Canary. They exchange MRI images between all these institutions, MRI images, clinical data which they have, because it's a lot of data, you need an optical fiber network to send it across. So I told them, if you have your C brain, I'll have my I brain, India brain. So we have now connected all the institutions in India doing on brain research. See, they were focusing on Alzheimer's. We can do Alzheimer's, you can do dementia, you can do stroke, you can do whatever you like. And share the images. Within these 40 institutions are connected. You can create various research groups. It's entirely up to us. We are taking it up only as model projects. Because many people think once you get the NKN, it's just like another internet. It's not an email service. It can provide you variety of services, including this kind of interaction. We have a cancer grid. We also have a biodiversity grid. Because India is a mega biodiverse nation. It is recognized globally. And if you go to the Forest Research Institute in Dehradun, what fantastic data they have on Indian forests. Similarly, data on Indian insects, viruses, animals, or whatever it is. If we can all be digitized in a way which follows a standard format, it becomes accessible to anybody. Any guy who wants to research in this area can use it. Now I come to my last slide. Of course, not quite the last slide, because I can't talk without going to nuclear. So these are the nuclear power plants in India. 7 of them are under construction. What you see in red over there. But I just wanted to show you this slide, which is the report on the role of the International Atomic Energy Agency to 2020 and beyond. The former Director General of IAEA, Dr. Mohammad El-Baradi, had formed this commission. I was a member of that. And our conclusion was that to face these two great challenges of the 21st century, energy security and the threat of climate change, nuclear is a very, very important option. And whatever has happened in Fukushima, where there was a failure of the secondary post-shutdown cooling systems because of the tsunami, the conclusion remains unchanged. What everybody has done is to review all the reactors that in the case of any extreme natural event, including the tsunami, nothing will affect the availability of water to continuously cool the reactor as long as the radioactive decay heat has to be removed. And as I said, energy security is the foundation for every other kind of security that one can think of, as water security, food and nutritional, environmental security, health security. Health security. See, you take any energy producing system, part will go to industry, part will go for urban consumption, but a part also goes to small towns and villages in India. They get better drinking water, better sanitation, better primary health care. So all these have an impact on health parameters, including the ultimate health parameter, which is life expectancy at birth. That is why I have always said that the Human Development Index, which has been defined by the United Nations in terms of 3 parameters, can be defined on the basis of just 2 parameters. The 3 parameters United Nations uses are per capita GDP, life expectancy at birth, and adult literacy. I prefer female literacy to adult literacy because it's a measure not only of literacy but of equity and justice in that society. That is, I won't talk about that. But per capita GDP can be replaced by per capita electricity consumption. More electricity you produce and consume, more are the goods that you produce. But just now, as I explained, health is also dependent on the availability of energy and electricity. So both these parameters, per capita GDP and life expectancy at birth, can be replaced by just this one parameter. And for a country like India, India cannot become a developed country unless its per capita electricity consumption goes up by 6 to 8 times. 6 to 8 times. From a 200,000 megawatt plus which we now have, we are talking of 1 million plus megawatt. And this is a focus for everybody, including, should be a focus for NITs, how to deliver it. That's why all energy options are important. Next 20 years we'll be burning mostly coal. But that is why we are going to the advanced ultra supercritical thermal plant. Advanced ultra critical super, that is, take the steam to 700 degrees, efficiency goes up. For every megawatt that you produce, you use less amount of coal, relatively. And you produce less amount of carbon dioxide. Renewables are very important for India. Hydro, from large hydro to microhydel plants. And also nuclear. All options are important for India. And you see, India, this Yukiya Amano, who was the Director General of IAEA, he came and talked in a lecture in Bach on 11th March last month. And he says, after the Fukushima Daiichi accident, some people predicted that nuclear power will go into decline. And he's from Japan, obviously, from the name you can see. However, the evidence suggests that this will not be the case. Actually, 60 reactors are under construction. 66 new reactors. 7 of them in India. China has said it will accelerate its nuclear power program. And very interestingly, the last country which started building a nuclear power plant was China. And 27 years later, the next country which is starting to build nuclear power plants is United Arab Emirates. That's the country you are here. Because I came in 2008 to Abu Dhabi when this was being discussed. And very clearly the feeling was, I think it is a very far-sighted decision that how long can you depend just on oil? And you can't make it entire economy dependent on just one product. And in fact, all that oil, if you can retain it for other users later, so you go nuclear. And by 2020, I think they want to go nuclear in United Arab Emirates. Of course, they have an agreement with Korea, South Korea, which is advanced nuclear power. Started with this AP. AP is the Westinghouse design. And Westinghouse design is, now they have modified it, they have improved it. AP 400, that's what's being built in the United Arab Emirates. India, he considers Yukiya Amano as a leader in the nuclear sector. And also, I will not go into the details of it, I talked more about it yesterday, how the importance of fast reactors and nuclear fuel cycles for close the fuel cycle. Take out the plutonium from heavy water reactor fuel, put it back into fast reactors, like the one we are building in Kalpakkam. If you are able to do that successfully, close the nuclear fuel cycle by recirculating, reusing the plutonium, same uranium will give you 50 times more power. The long term, close it with thorium. Then the same uranium will give you 600 times more power. This was a kind of an option for India because we wanted to be self-reliant, as Ambassador mentioned. My definition of self-reliance is immunity against technology denial. The more you deny, the more self-reliant I become. This is what was the way it was done, and we decided to close the cycle. Now, of course, uranium is more easily available to us, but he's talking globally that if you are able to do that, the uranium which will last you a few hundred years will last you a few thousand years. So Muhammad and I used to say nuclear is a near renewable source of energy, near renewable. Of course, solar energy is also nuclear energy. How many of you know? All of you know. It is fusion in the sun which gives rise to energy. When it comes here, we call it solar energy. And you know, here Amano wanted to also say that India's willingness to serve as a mentor for other countries. Let me come to the last, but one slide. See, the reason many people ask, why is it that in a developed country there is so much interaction between academia and industry, where it doesn't happen so easily in India? It's a question we are continuously asked. The answer to that, in my opinion, is that in an already developed country, there is a thermodynamic equilibrium between the knowledge in the academic system and the knowledge which has been transferred to or generated within industry. The two are very close to each other. That is why, of course, academics are always higher than industry. So the industry is waiting for new knowledge to come out of the academic system in a developed country. People like me, as he said, I am also a basic research scientist. We want to be in equilibrium with the academic system in the United States. Otherwise, how do I write papers in high impact factor journals and get my next promotion? Put it in my biodata, I have published in physical review letters and all that sort of thing. But Indian industry was a couple of notches lower, and this automatically caused a disconnect between Indian industry and the Indian academic system. But things, take it from me, are changing very, very rapidly in India. Nuclear and space, we are already on par. Some areas of defense research. Automobile, we are getting to be on par. As more and more of sectors of Indian technology begin to be globally competitive, then we will have to generate our own knowledge. And for this, NITs must prepare itself. See, suddenly you come and ask a professor, give me a PhD in this subject. Where is the PhD? There is no PhD. If you want from a professor in NIT or IIT or a university, for you also, from Thermax wants, let us say, you must tell the professor 8 years in advance. That is where your foresight analysis comes. Then he will choose the right kind of guy, train the right kind. At least 5 years you must give him time. And this kind of analysis, I think Indian industry must now start, and then start. Other way, you, as I mentioned to you, start interacting with the academic system. This is kind of an inevitable force which is now developing in India. We have seen it in the core advisory group for automotive research. We started machine tools, electronics and all that. That has enhanced the interaction between academia and industry, these three groups. See, this is my last slide. I have been thinking after I got your letter, how can NIT and the NIT alumni contribute to India's development? Of course, you can do many things. In my opinion, I'm setting it up, you know better. Maybe some of the suggestions may be wrong, but at least this is my thinking. See, if you can get an idea of the faculty openings in all the NITs, there's a tremendous number of these faculty positions are not filled, both in IITs and NITs. You create a database, alumni association, of these faculty openings and provide this information to faculty aspirants, not only to NIT alumni, but beyond. And I'm sure the embassy can help here. In all these databases, to get the information, you can also get, because you've got so many alumni right there in India, and of course people who are in high positions. Create a database of faculty in industry job openings in India. Of course, your first responsibility is to your country of where you are presently there. But if somebody wants to go back to India, to NIT alumni abroad, this information can be made available. In your own field, And maybe in your own alma mater, if you can create chairs or centers of excellence or contribute to it partly, that would be very good in very specialized fields. And sabbatical opportunities in the NITs you create for top faculty or scientists and technologists from abroad, so they can spend part-time in the NITs. And similarly, sabbatical opportunities of NIT faculty to come here. In your case, in the top Middle East industry or labs, or vice versa. Of course, you are all over the world. So this message is not only for the Middle East NIT alumni, all over the world. And also help in rural technology delivery in the proximity of your alma mater. As I said, I'm beginning to think now. See, we started a rural technology action group with 8 NITs now, 8 IITs. See, the problem, if you take the chain, how much? I'm finishing very shortly. Taking too much time is okay? No problem. See, if you take the chain research, development, delivery. Research, development, delivery. Very interesting paper in 2004 from MIT by a guy called Kenan Sahin, who said academic institutions are good in research, capital R. And this is what causes the innovation backlog in the United States. Now the same thing applies in a worse measure in India. That is why we are trying as far as industrial development is concerned, we are trying to create this academia-industry interfaces of various kinds. And particularly in those sectors which are beginning to boom, sectors which are beginning to boom tend to have a lot of cash. Cash flow is available. They would be more than happy to invest in research and development. Those which are weak, which don't have cash, they are not going to do, by and large, research and development. In the case of rural development, one finds that knowledge is there, but for some reason not reaching the rural areas. The problem is not so much of R&D, though that is also important, but more of delivery. So under ROOT-ORG, we work with voluntary organizations led by scientists. See, the weakness of my office is grassroots intervention. Unless you go and work with those guys, you don't know what their problems are. The voluntary organizations know that. My strength is my connectivity to all knowledge institutions in the country. So we must be able to talk the same language. So the scientists who lead these rural voluntary organizations, they know what the demand is for tech. They come and talk to us, and we find the best partner. That is in a nutshell. Of course, it's much more complicated than the simple things we have made. Now, we started with the IIT Madras and IIT Kharagpur. Now there are in 8. Now I'm thinking of starting it in some NITs also, particularly those which are which have got a strong presence in rural areas. So as you can see there, all of us can contribute to India's development in our own way. But I think there is one which individuals can do, and there are things which groups can do. And I think NIT alumni is a very important group which you can think of some things which you can do, all of you together, to help India's development goals. At the same time, of course, you must help to develop the country where you are presently present, which I'm sure you are already doing. So it's a great pleasure to be with you, to interact with you, and I wish you all the best in the years to come. Thank you very much.
Thank you very much, sir. May I request Mr. Ranjit to present a memento to Dr. Chidambaram. Thank you so much, sir. It's very difficult to summarize what Dr. Chidambaram has said, because he moved from one topic to the other and has enlightened us. And I'm sure for a person like him, 40 minutes to 50 minutes is actually insufficient. I think we can just go on for the entire day, you know, with awe, hearing him and his stories. In a gist, what he actually said was, India is poised to be in the rightful position to become a knowledge-based economy. There are already steps that has been taken in that area, like the NKN that he was talking about, and it is just a collaboration of the academics and the industry in a more interesting manner that can help, or in a more fruitful manner that can help it take to the next level.